Hello, welcome back. When I left off on the last video, I asked you to practice making box plots using the data for the residential per capita energy use for each state. You should have found that the median per capita energy use was 68, the upper and lower quartiles. The upper quartile was 74 and the lower quartile was 60.3. That gave you an interquartile range of 13.7. Using these quartile values, you could check to see if the data set had any outliers. Unlike the transportation data, you should have found that this set had no outliers at the high end, but had two outliers at the low end. Hawaii and California both have surprisingly low values for residential per capita energy use compared to the other states. And actually, let me go over and record the values for those because we don't need the states, we need to know what the values were. So if I scroll down, Hawaii was 23.9 and California was 35.9. To construct a box plot, we only need two more things. We need to know our lowest value that wasn't an outlier and our highest value, so let's go get those. Our lowest value was 53.5 and our highest value was 91.5. So if I put all of this together into a box plot, let's start with the axis. I'm going to go from a value of 23.9 to a value of 91.5, so let's try counting up by tens. Our median is 68, so that's right about here. That gets a vertical bar. Our lower quartile is 60.3. Our upper quartile is 74. So there's my box for the box plot. My upper extreme value is 91.5. So there's a whisker. My low extreme value, if I exclude the outliers, is 53.5. See about there. And I have two outliers. I have one all the way over at 23.9. And I have one at 35.9. So here's my box plot for that data. Looking at it, I can see some interesting behavior. I can see that many of my data points are grouped in this middle box, right? This represents 50% of my data, between 74 on the high end and 60.3 on the low end. I have another 25% sandwiched between 53.5 and the 60.3. So really my data is quite condensed for these three quartiles. The upper quartile is a little bit more spread out, suggesting that if I were looking at skewed, I would have a right skewed data set. But I do have these two extreme values on the low end, which are also pulling my data in the other direction. Okay, so hopefully you got a histogram, or a box plot that looked more or less like that. And speaking of histograms, I'm sort of previewing what's coming next. The next thing we're going to talk about is another way of visualizing data, another visual distribution, called the histogram. So let's head over to the PowerPoint for this, and we'll talk about histograms. A histogram shows how often the values of a variable fall into various intervals. You've probably seen these before. These look like bar charts that tell you how many times the variable fell within certain intervals. To construct a histogram, we need to do two things. We need to find the class intervals, and we need to build a frequency table that tells us how many times the data falls in each class interval. So let me summarize that over in our notes. To construct, the first thing we have to do is find the class intervals we want to use. And then build a frequency table. That counts how many values fall in each interval. Okay, so let's head back to the PowerPoint, and that will tell us the first thing we have to do before we can define our class intervals is decide how many class intervals we want to use. We're going to divide the range of values up into equal length intervals, and depending upon how many we use, our graph may be more or less useful. If we use too few, our graph isn't going to give us enough information to really be helpful. But if we use too many intervals, the values are all going to be pretty small if I split it up too finely. So what I need is a nice number in the middle, a number of intervals that gives me a picture of what's going on without breaking it up into too many pieces. And there's a nice heuristic that helps with this called the square root heuristic. A heuristic is sort of a guideline. You don't have to stick to it exclusively, but it's a good guideline to keep in mind. And what the square root heuristic says is that if we have a total of n values, we should use the square root of n class intervals. Okay, so if we go back to our example for the data on per capita energy use for transportation, we have one value per state, so we have a total of 50 values, which tells us that we should use the square root of 50 class intervals. We have extreme values of 56.5 and 220.4. This will tell us how to find our intervals, and that gives us a total range of 163.9. So let's head over to our notes and find the class intervals for this example. Okay, so 50 values tells us we should use the square root of 50 intervals. You take the square root of 50, you get that that's approximately 7.07. Well, we can't split it up into a decimal number of intervals, so we'll just round to 7. Let's use 7 intervals. We need now to figure out what the lengths of the intervals are. That's why I told you the range. Let's go back. The range for this example was 163.9, and And I want all my intervals to have the same length, so I'm going to divide by 7. That turns out to not be a very nice number, so we're going to round it to 1 decimal place. We'll use the length of intervals to be about 23.4. We'll see that this means we have a little bit of extra space that we will choose an interval for, but that's okay. So 23.4 is how long each interval is going to be, roughly. Okay, so our first interval will start at our lowest value, and go 23.4 units, which brings us to 79.9. So our first interval is going to be all the values between 56.5 and 79.9. Our second interval will start at this 79.9 and go 23.4 units, which will bring us to 103.3. So I'm just taking my starting value and adding 23.4 to get the upper value. Let's see, the next interval is going to start at 103.3 and go 23.4 units, which will bring us to 126.7. The next one starts at 126.7. When I add 23.4 to that, I get 150.1. Then we'll start at 150.1. Add 23.4 will take us to 173.5. 173.5 plus 23.4 brings us to 196.9. And 196.9 plus 23.4 will bring us to 220.3. Those are almost our 7 intervals, except this 220.3 is too low. We're off by 0.1. Our biggest value is 220.4. So let's go ahead and adjust this so that we have an interval for our highest value. And we had a discrepancy because we had to round this value here. 163.9 divided by 7 is not a nice decimal. And so we had a little bit of rounding error, but that won't impact our picture actually at all. So we're just going to round up to 220.4, and those will be our 7 intervals for this example. Okay, let's go back over to our PowerPoint and see what we need to do next. Okay, once we have our class intervals for a data set, the next step is to make a frequency table, which is a table that shows how many data values lie in each of the class intervals. So we're just going to count the number of data values that are between the 2 endpoints of the interval. There's sort of only one technicality that might come up, which is that you might have a data value that lies exactly on the boundary between 2 of the class intervals. If I go back, right, I had these boundaries that showed up on both class intervals. So the question is, what do I do if 126.7 is one of my data values? Where does it go? And the convention for a situation like that is to count the data value in the class interval with the larger values, to put it in the right interval instead of the left interval. That's not, right or wrong. That's just the convention. That's what people usually do. So if I'm using histograms to make comparisons between data sets, it's important that I always do the same thing. And this is what people do. So that's what we'll do as well. Okay, so let's go back to our state energy use data and make a frequency table. Okay, and I'm going to go ahead and I've already got my interval values, so I'm just going to make another column where we record how many values fall in each one. So if I go over to my data table, I'll just count. Let's see, the first interval goes from 169.9 to 220.4. So let's count how many are in there. I get two that fall between those numbers. So there's 2. The next one falls between 173.5 and 196.9. So let's go over 170. This one's too low and this one's too big. So there are actually no values in that range. The next one is between 150.1 and 173.5. I get 2 in that range, this 166 and this 173.2. The next one is between 126.7 and 150.1. Okay, 126 to 150. So I've actually only got one value showing up in that interval. Okay, I've only got 3 intervals left, and I've got a lot of data points left, so they should start to get bigger now. 103.3 to 126. 1, 2, 3, 4, 5, 6, 7. 79.9 to 103.3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 in that. Okay, and then all the rest should be in the range between 56.5 and 79.9, but let's count, and we'll use this as an opportunity to double check our counting. So 56.5 to 79.9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And I should check, in case I miscounted. All of these should add up to the total number of values. So do these add up to 50? And the answer, if you add those, is yes. Yeah, they do. So I probably counted correctly as I was setting up my frequency table. Okay, so we have our frequency table for our data set of state energy use. Now that we have a frequency table, we're ready to draw a histogram. This is a bar chart that represents the data in the frequency table. The y-axis is going to count the frequency, so how many values appear in each interval, and the x-axis is the range of the data values broken up into the class intervals. Let's see, and I think, yeah, okay, so before we look at example 4, let's finish out our data set. We have this frequency table, so let's use it to build a histogram. If I look at the frequencies I have, they go all the way from 0 to 19. So my y-axis is going to go from 0 to 19. And my x-axis, like I said, is going to be the range. And the low value that I have is a 56.5, so that'll be my low end for the x value, and my high value is 220.4. So we'll need a pretty long axis. Okay, let's count off. So for histograms, it's not so important to start at 0 because it will be obvious where your bars start. So let's just start counting around 50, and let's count off by 50s. And I'll mark off the 25s in between. Okay, and like I said, the y-axis is going to be the frequencies, so I've got 0 to 19, so let's say here's 10 and 20. Okay, so let's see. My first interval went from 56.5 to 79.9. So 56 is going to be right about here. 79.9 is going to be right about here, and that has a height of 19. So there's my first bar from my bar graph. The next class interval went from 79.9 to 103.3. And also had a height of 19. So there we go. Since I'm doing this by hand, let me go ahead and label where these intervals are broken, since these are all supposed to be the same width, but it already doesn't look like they're the same width. And these should be the same height. These are both 19. Okay. The next one went from 103.3 to 126.7 and had a height of 7. Here's 125, so 126. It's just a little bit past that. Okay, the next one went from 126.7 to 150.1 and had a height of 1. So that will look like that. The next class interval went from 150.1 to 173.5, which is going to be close to this 175, and had a height of 2. Okay, two more. I went from 173.5 to 196.9. That's going to be over here. I had no data points in that class interval, so our height is going to be at 0. And then my last class interval went from 169.9 up to 220.4. And had a height of 2. I had 2 values in that range, in that interval. Okay, so here's my histogram for the energy use per capita for transportation by each state. I can see really clearly from this histogram that I've got a grouping of data points in the low values. And then I have this tail that goes off where I've got some stragglers. I've got some other states that have really high values, but not many of them. So I can see from the histogram that this is a right-skewed data set. Okay, that's great. I feel like we've done everything we can with that data about transportation energy use. Let's go back to the PowerPoint and look at one more example building a histogram, because I want to make sure that we practice deciding how many intervals to use and then finding them. So I want to look at data values that are given in your book in example 4, that are coming from a study that measures phosphorus concentrations in lakes in Puget Sound. They collected 28 samples from different study sites around the region, and these were the concentrations that they got. So let me just take these concentrations and copy them over to our notes. Okay, so there we go. And these again were the phosphorus concentrations in those different lakes. Okay, and let's make a histogram. Before we can make our histogram, we have to choose our class intervals. So how many class intervals should we use? Well, remember that to find the number of class intervals, we're going to take the number of data values and look at the square root. This has 28 data values, so we're going to look at the square root of 28. And that comes out to approximately 5.3. So we should really choose 5 or 6 intervals to get a good picture of what's going on. To choose 5 or 6, we could go with 5 because this number is closer to 5. But if we choose 6, it's actually going to make our life easier. So we're going to go with 6. And the reason that is because if I look at the range of this data, it goes from 28 to 24. Sorry, it goes from 28 to 4. So I have a range of 24. And 24 is evenly divisible by 6, but it's not evenly divisible by 5. So if I go with 6 intervals, the length of each interval comes out to a nice even number. It's 24 divided by 6, which is 4. Whereas if I go with 5, my length is going to be 24 divided by 5, which is a decimal. It's not terrible, but let's go with a nice round integer since we can. So we'll go with 6 intervals, and we already know that the length of those intervals is going to be 4. So my intervals I'll have one that goes from 4 to 8. I'll have one that goes from 8 to 12. I'll have one from 12 to 16, 16 to 20, 20 to 24, and 24 to 28. So there are my 6 class intervals. And now we need to build a frequency table, and I'm just going to build this here. So here are my class intervals, and in this column I'm going to put the frequencies. So for 4 to 8, if I look at my data list, I have 2 values that fall between 4 and 8. Between 8 and 12, we do have a value of 12 that's on that border. We're not going to count that in this interval, we'll count it in the next one. So remember, if you have one on the border, the convention is to count it in the interval with larger endpoints. So between 8 and 12, we're only going to count 10, 11, and 11, so we get 3. Between 12 and 16, I'm going to count this 12, 13, and these 15s. But same thing, I'm not going to count the 16s that are on the border. So we'll go like this. Okay. 1, 2, 3, 4, 5, 6, 7. Between 12 and 16. Between 16 and 20. Not counting 20. I get 9. Between 20 and 24. Get 5, and between 24 and 28, I get 2. And let me just double check. These should all add up to 28. And they do. So I probably counted correctly, which is always good. Okay, now that I have my frequency table, I'm just going to record this in a histogram. So let's build our histogram over here. My data values start at 4 and go towards 28, and let's go ahead and count off by 4 since that's the length of my interval. So we'll go from 4 to 8 to 12 to 16 to 20 to 24 and to 28. And I have frequencies that are going from 2 up to 9. Okay, so for 4 to 8, I had 2. So I'll make a bar at a height of 2. For 8 to 12, I had 3. For 12 to 16, I had 7. For 16 to 20, I had 9. (20 to 24) had 5. And 24 to 28 had 2. Okay, so there's my histogram for that data. Okay, and let me just go back to my PowerPoint for some concluding thoughts. We have talked about 2 visual representations of data. We talked about the box plot and the histogram, and they do emphasize different properties. The box plots tend to tell you where the values of your data are grouped. They tell you where the middle is, and they tell you where the middle 50% are. The middle 50% of your data falls in the actual box, and then it gives you an idea of how far the spread is using those whiskers. Histograms, on the other hand, don't really tell you where the middle is. You can kind of see it from the shape of the graph, but what they emphasize more so is where your most common values are. What numbers are showing up in your data table most frequently, because those will be the places that have the highest bars on your histogram. But they both communicate to a certain extent or more where the center of the distribution appears, how widely dispersed the values are around the center. So both of them do give you a really good idea of spread. Though box plots differentiate between spread and interquartile range. So with a box plot you can see where the outliers are, and with a histogram you can't. And with both of them you can get a good idea of whether or not the values are symmetric around their center. This is easier to see from a histogram, but we talked about how you can see this from a box plot as well. And this is important because as we go forward into the next section, these are 3 properties of a data set that we're going to be interested in measuring in different ways. So the center, the spread, and the symmetry of our data set are going to be important going forward. Okay, we'll stop there.